Just a week after its first images were shown to the world, the telescope may have found a galaxy that existed 13.5 billion years ago.
NASA says it just found a new planet.
Shocking, right? Yeah, the James Webb Telescope spotted it just outside of our solar system.
The James Webb Space Telescope, humanity's most powerful eye in space, has recently sent back data so staggering it threatens to reshape our understanding of the cosmos. Astronomers analyzing the telescope's ultra-deep field imagery have identified a mysterious cosmic phenomenon, an apparent disappearance of over 900 billion stars across various galaxies. This isn't a poetic exaggeration or miscalculation. It's a solid, data-backed observation baffling even the most seasoned astrophysicists. These missing stars, observed in galactic regions where light once blazed with stellar activity, have now dimmed or vanished entirely without the telltale signs of collapse, supernovae, or black hole consumption. What the James Webb has unveiled could redefine not just astrophysics, but the very fabric of cosmic theory. Before we start, smash the like and subscribe buttons for more updates. Initially, the project aimed to peer into the deep past, capturing light from galaxies formed just a few hundred million years after the Big Bang. Webb's incredible infrared sensitivity allowed it to look beyond the reach of any previous observatory, capturing light that's been traveling through space for over 13 billion years. Scientists were expecting to study the formation and distribution of stars in these early galaxies, but instead, they noticed something extraordinary. Entire regions of space where star populations appeared to have thinned out at a scale that defies explanation. By comparing older archival data from the Hubble Space Telescope and other space-based and ground-based observatories with the new, ultra-high-resolution images from Webb, researchers mapped these galaxies' expected stellar content. What they found was shocking. In some cases, over 40% of the stars anticipated to be present based on earlier data had either drastically dimmed or vanished from Webb's sensitive instruments. The cumulative estimate across all observed regions amounted to nearly 900 billion stars missing or no longer emitting in the infrared bands. This wasn't merely a matter of dimming stars slipping below detection thresholds. Webb's instruments are engineered to capture even the faintest signals in infrared wavelengths, the afterglow of starlight absorbed and re-emitted by cosmic dust. The voids left by these stars are more than empty spots in the sky. They're scientific sinkholes that challenge the most fundamental principles of stellar evolution and galactic formation. One of the most perplexing aspects of this discovery is the sheer uniformity of the phenomenon. The disappearing stars were not clustered in just one or two galaxies, nor were they confined to specific types of galactic structures. Spiral galaxies, elliptical systems, irregular dwarfs, all showed some degree of the anomaly, and the effect was not concentrated in the nearby universe. It spanned both relatively recent galactic epochs and the deep ancient past. The consistency suggests that this is not a local fluctuation or instrumentation artifact, but something possibly intrinsic to the universe's large-scale behavior. The implications of this are nothing short of monumental. For decades, astronomers have constructed their understanding of cosmic evolution on the bedrock principle that stars, once formed, follow a predictable life cycle. A star is born from a cloud of dust and gas, burns brightly for millions to billions of years, and ends its life in a more or less observable event, a supernova, a planetary nebula, or a silent fade into a white dwarf. The absence of catastrophic markers in these galaxies, no excess supernova remnants, no ballooning black hole activity, no sudden outflows of gas or radiation, suggests that these stars did not die violently or even conventionally. They simply faded, as though their mass or energy had been siphoned off, absorbed, or even translocated. The leading hypothesis currently under discussion is as exotic as it is unsettling. Some researchers are exploring the possibility of unknown forms of dark matter or dark energy interaction. These theoretical constructs already make up the bulk of the universe's mass-energy content, yet they remain largely invisible and poorly understood. It's possible that some form of dark energy fluctuation or dark matter phase transition is interacting with baryonic matter, the normal matter that makes up stars, planets, and humans, in a way that renders stars undetectable or removes them entirely from our observable realm. Others are pushing even more speculative boundaries. Could there be macro-quantum events at work? where entire star systems tunnel into different states of energy or existence, akin to quantum disappearance on a cosmic scale? Alternatively, some theorists are entertaining ideas from the fringe of cosmology, variable physical constants across space-time, or multiversal interactions where gravitational or quantum entanglements might bleed star systems between different cosmic dimensions. Though these theories may sound far-fetched, the data cannot be easily reconciled with any known astrophysical process. Observations show that the disappearance did not result in gravitational disruption. The galactic structures remain intact, stellar orbits unchanged, and interstellar gases undisturbed. That suggests the missing mass is not exerting gravity anymore, as though the stars were erased not only from visibility, but from physical interaction with our universe. That raises difficult questions about the permanence of matter and energy. If stars can vanish so cleanly and so silently, what does that say about the universe's long-term stability? On a more grounded level, some teams are examining whether high levels of cosmic dust or unexpected chemical compositions could account for the dimming. However, Webb's ability to pierce through dust with infrared observation strongly argues against this being a simple case of obscuration. If dust were the culprit, it would leave a distinct signature. The infrared light would be absorbed and re-emitted in predictable thermal bands, which are not being detected in the corresponding regions. Moreover, the consistency across galaxies of different metallicities and dust content weakens this explanation. Another line of inquiry is whether stellar populations are behaving differently at high redshifts due to unique early universe conditions. Perhaps primordial stars had properties we've not accounted for, shorter lifespans, higher volatility, or transient modes of existence we've never observed locally. Webb's ability to reach back into cosmic infancy might be revealing not a disappearance, but an entirely different mode of stellar life cycle. However, the numbers still don't add up. The scale of the dimming and its presence in more recent galactic environments suggests this isn't just a case of unusual stellar youth. Some even speculate that intelligent manipulation might be involved, an artifact of hypothetical extraterrestrial civilizations on a scale beyond Kardashev Type III, capable of harvesting stars themselves for energy or converting them into computational matter. Though extremely speculative and currently lacking any supportive evidence beyond the disappearance itself, this hypothesis draws increasing interest among those who believe that only intelligence could operate with such subtlety and precision on a cosmic scale. Whatever the true cause, this event forces a re-evaluation of many long-held beliefs. Stellar population modeling, galactic evolution algorithms, even the parameters used in cosmological simulations all may need to be recalibrated in light of these findings. If 900 billion stars can vanish in a way that defies current models, then the reliability of many other inferred cosmic measurements becomes questionable. Distance estimates, star formation rates, and even dark energy calculations rely heavily on assumptions about stellar light output and life cycle behavior. Undermining those assumptions has ripple effects across cosmology, physics, and astronomy. Astronomers and physicists around the globe are now racing to replicate Webb's observations using alternative methods and instruments. Gravitational lensing studies, neutrino detection arrays, and wide-band radio telescopes are all being pointed toward the mysterious voids. If these stars have somehow shifted their energy expression to non-visual spectra, or are leaving faint gravitational imprints, it could offer new ways to probe matter beyond light. Meanwhile, theoretical physicists are working in overdrive to devise mathematical models that might account for non-destructive matter disappearance on such vast scales. For now, the cosmos remains silent about the mystery. These stars, so immense in their birth, so luminous in their prime, have vanished without echo, leaving behind only questions and a darkness deeper than night. Yet in that darkness lies opportunity. The James Webb Space Telescope was built to challenge our knowledge and push the boundaries of human understanding. In revealing the disappearance of 900 billion stars, it has not failed. It has succeeded in its most profound mission, to show us that the universe is still full of unknowns, still vast in mystery, and still capable of humbling even our most advanced tools. Rather than marking a limit, this event may represent a beginning. The dawn of a new era of astrophysics where matter, light, and even existence itself must be reconsidered. The stars that once gleamed and are now gone may yet speak, not through light, but through the very shape of reality they've left behind. And as Webb peers deeper into the cosmic veil, humanity stands on the precipice of the most extraordinary revelation in its brief cosmic journey, that the universe, vast and ancient as it is, may still be in the act of becoming something even stranger. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on disappearing stars? What do you expect in this video? We want to hear from you. Thank you for watching, and see you next time.